Yes. I mean, I'm going to show you a work in progress. Okay. It's important to put a big disclaimer here. I think one of the cool things was that I was able to actually start working on this as Chris was finishing his work on libraries, which again I haven't published it as a library yet, but I think there's something really amazing in terms of like our ability to innovate and experiment in generally in around Wing once we have this ability of publishing libraries, because
Right.
the foundation is becoming more stable, and as it becomes more stable, it's harder to change, and it's more bureaucratic. You need to get someone to review your pull requests. We want to make sure that there's documentation for everything, right? Like the bar is getting higher and higher to change stuff at the foundational level. But then if I want to just experiment with something like containers, or experiment with something like websites, or experiment with whatever, AI agents library, now very soon is going to be super easy. But now I can actually just publish these libraries and people can start using them. And so that's been a really cool opportunity. We do want to include containers in the foundational library, right? Like we believe containers they need to be first class building block of the Wing Cloud Library, and long running services are. We actually have cloud.service already, but we don't have implementation for cloud.service on AWS and GCP and Azure. And the plan is to basically use the container API in order to implement these this high-level long-running service API. So that's going to be super interesting to see how that plays out. So let me show you what I have. I'm going to start with the API and the experience, the user experience, and if we have some time, then I'm happy to dive a little deeper into the implementation and the pain, all the pain. So let me make sure that I have everything ready here. I was trying to make some tests before sorry. Give me a second. Let's see.
We're all waiting. No pressure,
man. Present my screen. And I have my entire screen. Okay. So let's see. So currently, just to make sure, this is available under Wing containers. I can't say it's available yet, right? Because it's not really ready for consumption, but it's slowly being developed under this repository under my account, and so. And I'm slowly gathering the roadmap, and you can see little checkboxes slowly filling in on all the holes, and it's already doing quite a lot of things. Let me show you the basic experience. So let's bring this library over. So currently I'm just bringing it as a module, as a local module, and the main API here is workload. And you can see Mark's new documentation stuff over here.
Elad, do you mind zooming in a little bit? Kind of enlarging your font?
Yeah, sure. Is it better?
Yeah, I think it. I don't know. Let's see.
Okay. Yeah. And so you see that basically workload has two required keyword attributes: name and image. Everything else is optional. And so the easiest thing to do is to basically start with something like that. Let's see. Let's start by just deploying a container from Docker Hub. Kind of like a simple HTTP echo container. We'll call it HTTP echo. And the image is, I think I remember. I have it somewhere in my tests. Let's see. Simple. So yeah, HashiCorp has one. Okay. And now HTTP echo exposes a port. And so in order to be able to actually connect to the container, if I just deploy this, I'm going to have a container deployed, but I don't really have any ability to interact with that container.
Right.
And so the port that it exposes is 5678. So basically, I'm going to do port 5678, and that's it. So basically, deploy this container called HTTP Echo with 56678. This is very, very straightforward. I'm going to wing it.
Wait, I need to understand this a little bit. The container itself uses the 5678, and you're just exporting it. That's what's happening. Right
basically, I'm not. The current API doesn't have any explicit way to say which external port it exposes.
Okay.
Basically, the internal port is 5678, and that's it. I want to be able to access this container.
Okay.
And so you see, I have a Wing console started here, and you see that it pulled the image and it started it and it executed it with these parameters.
Awesome.
And now I actually want to interact with it, but I don't really know. I don't really know how, right? Because I need the URL of this container. And so let's do this and create a cloud function.
Okay.
Call it get URL and put this here. I'm going to call it echo. And here I have an API that says URL.
Nice.
It actually also have an API called internal URL. And that's an interesting distinction between the public URL of the container and an internal URL. Because in many containerized, container orchestration systems, you have this ability to actually interact between microservices that are running within the same cluster, but they don't necessarily have to have an external public, load balancer exposed to the internet. And so we also have this ability to specify whether it's a public workload or not. And as long as
would be the result if I try to access the external URL when it's not public?
There's no external URL, so there's going to be null.
Okay, awesome.
So, but I think that I'm not sure that this internal thing is actually working. So the internal thing in the simulator is basically going to allow Docker to Docker communication. So if I have multiple workloads running on my machine, then there's a way for multiple Docker containers to interact with each other. This special host.
Not Cloud Function to be able to interact with it, but Docker to Docker. That's what you're saying.
Exactly. If I want to interact with it from a Cloud Function, I need to make it public. So now I have the URL here, and so I do this and then log URL. And then I'm going to save this, and you see that as soon as I saved it, it stopped the container and it started it again. And now if I call this thing here, I get a URL, and I can see the URL.
Nice.
And we get a really nice experience, right? Like I think like this guy has like the ability to specify. Again, I don't remember the API exactly. Let me see my test. You can actually specify like an argument that says what's the output. So let's just do something like this. Eyal. And this is restarting.
It will have a new public URL, right?
It'll have a new public URL.
Which is annoying. We all know.
Which is annoying. We all know.
Yeah.
But now we actually have
Eyal.
And so we get this like nice developer experience. The plan is to actually add some more hot reloading capabilities for the local experience. Because you saw that it actually took some time for the container to be stopped and started. And I do have some optimizations already around changes. And so if for example, if you have your local image and you haven't changed it, it won't rebuild the image, right? So it does have some initial optimizations there, but I think like we definitely need some more, right? Like I feel like that's definitely it's working, but it's not as fast as I want it to be in a sense. Okay,
we got a short kind of explanation on the bridge networking model in Docker. that are running on local source and post, and the combo gives you a service name to the outside world. Awesome.
Okay, so now let's deploy this to AWS. And I'm going to do win compile -t tf AWS. And now let me talk about how containers are implemented on AWS. And so our default implementation is using an EKS cluster. We kind of made a decision to start with Kubernetes as a container orchestration system because it's, we see it a lot in the industry, and it's also some commonalities across cloud providers, and that means that being able to deploy on EKS has some similarities to being able to deploy on GKE or other Kubernetes systems.
Right.
And the way we do it is we basically generate a Helm chart for your application. Now, if you're just running win compile -ttf AWS, and let me do that for a second.
Okay.
And I'm going to look at the target here. What you'll see is basically an entire EKS cluster,
right?
Which is a very messy, very messy deployment, right? Like it actually, like doing. I actually wrote the original version of the EKS CDK construct, and I spent about 3 months doing that, kind of like learning exactly all the degrees of freedom of EKS and exactly how it's deployed. And I remember having this feeling is like, oh, thank God that's the last time I have to do this, because I said, we're building the EKS module for EKS CDK construct, and now I had to do this again. And I've actually done this with the EKS module for Terraform. And I'm going to show you the code a little bit later, but it is still extremely hairy, right? Like this whole thing. But the default implementation is basically that it creates a cluster for your application, which is not a very common
pattern, right. Usually, right? You don't want to. Other people will create the cluster for you, right? I mean, you have an existing cluster.
Yeah, usually there's a cluster is usually a shared resource in many teams, very much like a VPC, right? Like a VPC is also usually a shared resource. And so what I've been experimenting here, and that's something that we want to support more deeply, I guess, in the framework, but I've been experimenting with this idea of being able to actually provide either, so the default implementation is batteries included, right? Like it's like this is just going to work. But you can actually also specify a values file. And the values file is basically your way to connect to the EKS cluster. And I guess I shouldn't be showing it.
And now you're sharing. Okay, so that's an L, S, and a 0.
Yeah, it's okay. I'm recycling these clusters every time. Okay. Now, the reason I needed this, this is something that I plan to do from the get-go, but the reason I needed this was because I really, like, creating an EKS cluster takes about 20 minutes. Okay. And so I couldn't really iterate, right? Like, there's no way for me to iterate. So now what we're going to do, let me delete the target, and I'm going to compile. We're not going to wait 20 minutes to create an EKS cluster. So now I'm just going to pass the values file and provide my application. And now it's basically compiling to connect to the existing cluster. And so if you see the Terraform here, you'll basically only see there's some stuff that's related to the function, actually. There's a function here that I created. So those are not really related.
Right.
We can even remove it maybe for now. Let me do that. Not to confuse
our viewers.
Our viewers, yeah, exactly. And so here you can see the basically Helm release. So that's basically a Helm resource. And you see that there's basically a Helm chart created for this application based on the workload definition. And there's a bunch of information here.
Wait, where do I see, before you show us the Helm release, can you go back to where is the reference to the existing
to the Helm chart?
To the existing EKS.
Okay, the reference happens here. Basically, when you're defining the Helm provider in
Oh,
Terraform,
interesting.
you're specifying the
Okay.
Kubernetes connection information.
Awesome.
And then that's basically it, right? Like the Helm release. So I can actually provide any Kubernetes, right? Like there's no constraint in terms of like which Kubernetes
Right.
cluster. And
And
then
it uses the same mechanism, the resource mechanism that Terraform does to upload the files, and then
yeah, and you see, this is basically just one resource. This entire application is just one resource.
Interesting.
Which is pretty cool. I think like it's a pretty nice.
The file itself can be a bunch of resources, right? I mean, Kubernetes resources.
Yeah, exactly. The Helm chart may include multiple resources, and that's what I showed you earlier. So it basically has like
so what do we have here?
A deployment, right?
Right.
And it has a service,
right?
And it has an ingress because we requested that the service is public. So if I actually remove the public from here,
so we're not going to have the ingress at all.
We're not going to have the ingress, right?
It changes the file name, right?
That's why. Yeah, it changes the file name, so I think it's supposed to be here. Yeah.
Yeah.
So this just includes the service and the deployment.
Yeah, it didn't delete the old file.
It doesn't delete the old files.
Right.
Okay. Shall we try to deploy this?
Of course. First of all, this is awesome, man. This is the first time I'm seeing it, so it's crazy. It's awesome. It's the first time we're seeing basically a Helm chart as part of our deployment. That's a first, right? It's the first time I'm seeing connecting into an existing resource. It's something that we've talked about a lot. And let's see. So what will deploy do? What does Terraform deploy? What does Terraform apply actually does in this case? So
it basically does Helm release.
It does Helm. Yeah, it does that.
Helm deploy, Helm release, Helm install, I think.
Helm something.
Helm install, yeah.
We have a question. What's the? When you spin up the Kubernetes cluster, it kicks out the kube config. File for you to connect. Nice. It doesn't. I'm pretty sure it doesn't, right? When you spin up a Kubernetes cluster, it kicks out a kube config file for you to connect. Do you create?
Yeah. So basically, in AWS, when you have EKS, there's a way to. Yeah, there's a command called update kube config.
Got it.
You can basically do this, and you specify the name of the cluster.
Awesome.
So in my case, the name is you can find it here in the values file, right?
In the secret file.
Yeah. Wing EKS in this case. Okay, so this was deployed, and now let's check our Kubernetes, and so you see that now I have my service and my deployment and my replica set, and
where did you state the replica? I mean, why do we have two replicas?
Deployment is that's the default replicas, and I can actually specify it here. So I can
change it.
10.
Okay. Okay.
And
compile.
Let's compile.
No, the Terraform plan will not be helpful here, right? Because it doesn't look inside the Helm chart. It just shows you that the Helm chart is different.
It's going to show that the Helm chart has changed, you see?
Yeah, makes sense.
kubectl. So yeah, we saw the pods, we saw the service, and we can also see the ingress. And you see this is basically a load balancer, an ALB.
Yep.
And so if I access it, it actually takes some time for it to load, but it's
what do you mean load? For the latency or
the ALB to actually
to be connected?
Health check the instance and onboard a new instance. So
do you have health checks? Can I configure health check? Can I say
there's currently only support for readiness probes. But I'm going to also include health checks.
Readiness is basically just to make sure that this is on, right? I mean, you can do
initialize, yeah, like that. All the dependencies basically are ready for.
And what's the API for the readiness? What does it accept?
Basically a URL.
A URL?
A ready or something like that, or ping.
And it needs to return a 200 or something like that?
Yeah, exactly.
Got it. Wow.
The other thing that's actually working, which is...
Did the 10 replicas work? Because I'm not sure. I think you're trying to...
I'm not trying to hide it. Let's see.
Oh, it just finished. Okay. It worked, man. Wow. This is awesome, man.
This is using Fargate. This is using Fargate as a default, which means that I can basically request any number of until I reach my soft limits. But it'll basically allocate hardware as required, or like compute resources as needed. But the EKS configuration, the EKS actually have like an EKS. Let me show you.
Yeah. Elad, I'm thinking about this. You're using the kind of a public Docker image in this example. Can I use something? Does it have an ECR behind the scenes? Can I use my own image?
Let me show you. I wanted to show you that. Okay. So let's say I have this front end Docker file.
Okay.
Right. Nice. And it's basically a stupid node program that shows this hello wingnut stuff and opens a port on 3000. Okay. Super simple.
Yep.
So let's create a new container. New container workload and call it front-end. And image is going to be, so now instead of specifying a Docker hub image, I'm specifying ./frontend, which tells the workload class that this image is a local image.
Okay.
And the port is 3000. And I guess that's it, right? Like it doesn't need anything additional. I probably want to do it public as well.
Right.
And let's do this for now and put FE here.
Okay. So we're running this locally.
And so now we just saved it, and you see that it's basically failing on something. What does it say?
Docker run detached.
I'm able to start container process. Oh, I think I haven't changed it to an executable.
What needs to be an executable?
The index file, because the Docker file says that the entry point is this. And so it doesn't go through node, right? Like, so basically the index file, has like a...
Okay, I see. Yeah.
It's already reloading.
That's nice. What happened behind the scenes? Does it build? I mean, does it build?
It builds the image.
Builds the image. And you're not doing any performance optimization right now, right? It's not. It's actually building the entire image every time.
It builds. It builds the entire. I mean, it uses Docker. Let me restart that. I think that's it, right. So
yeah, wing it.
I need to re-wing it. Wing it. Decided to run on dark mode now. Still not working. Why not? Executable now. Let's see. We really need to get these logs up here.
The pre-flight logs?
Yeah. Unable to start. Yeah, it sounds like it's the same problem.
Unable to start container, appendix, permission denied, unknown. Does it? It's /app because it does. Okay.
What am I doing wrong? Let me see.
Where is the /app? Where is the /app?
It just adds it to the container.
Okay. It adds, and
if I go to, let's see. I can just Docker build, run.
So there's a question that Chris is setting up, is asking, does the simulator use Minikube or something like that?
No, it's basically just running Docker locally.
So there's a decision here that you're not abstracting Kubernetes, you're abstracting an orchestration, a kind of a Docker Docker orchestration, where basically Kubernetes is an implementation of that. And in the simulator, you're just running Docker.
Exactly.
So you won't have replicas probably on the local host. You haven't implemented the replicas.
Correct. Let's give it another run.
Was the Docker compile running? Was it able to run?
Yeah, it seems like it's running, and I don't know why it's. Let me try. I don't know if that's the reason, but I'm gonna try and do this anyway.
Okay. What happens if you do Docker PS right now? What's running on your machine right now? The HTTP echo.
I'm actually using Orb Stack, which is pretty neat.
Okay. Okay. Can you show us the permission of the index.js file? ls.
No, sorry.
Well, this is exactly why we have you behind the scenes. You're trying to figure out what's wrong here.
Entry point. Up index permission denied. It's weird because it's definitely did work. But you know how demos are.
Yep.
Let me see. I'm going to take one of the tests that I have here.
Okay. Same.
This looks like the same, right?
You changed the expose.
Yeah, this is 1000, and this is just a little
What's
bit.
the permission on this file? Can you show us the output of ls?
Yeah.
And your file? Sure. No.
Looks the same, right?
Yeah.
And the weird thing is that when I built it locally, when I build it manually, it actually worked. So it sounds like it might be something in the way the build command that might have changed. Okay. Weird. Maybe the name of the file was wrong. I don't know. Whatever.
Who knows?
Okay, now it's running, and I'm going to get the URL.
So now we've built this thing locally. I mean, and it's still running, and
the port is a different port. Give me a second.
Yeah, it was 4,000. Now it's exactly. So now you've built this locally. The previous example, you basically fetched the Docker image, right. And now you're building this locally and running this locally, and the result 12. What's in the code over there?
Result 12.
Okay, nice.
And now if I do wing compile, right?
Right.
Let's keep this guy.
Okay.
And Terraform, fine.
Are we going to see any change? We're not going to see any change, right? The Helm chart is basically the same, right? But
no, first of all, it's another Helm chart. And second of all, you'll notice that
What do you mean another? What do you mean another Helm chart? Another Helm file?
I have another container, basically another workload.
Is it another Helm file? Oh,
yeah, it'll be another Helm file.
Two. I'm not sure I understand. Are there two Helm files right now, or just a single Helm file?
There's going to be two, one for each container, right? One for the front end.
Yeah.
One for each workload, right? One for
that's an implementation detail. That's not.
That's an implementation detail, definitely.
Yeah.
But it's usually the way you do it, right? Like it's basically a Helm file per application or per workload, right?
Yeah. So what you're saying, you usually use the deployment, the service, and the ingress on the same. It makes sense to put them in the same file.
They're kind of that's how I think a lot of people.
And I think it makes sense also from a diff perspective, from an applied perspective. What has changed? This hasn't changed, and this has changed.
Exactly. So now I have this Helm release of front end, but I also have a new ECR repository.
So it figured out that this is not something that we're building because of the / that you had. That's something locally, and then automatically it added an ECR
with lifecycle policy and whatever.
I don't know what that means. What does that mean?
Lifecycle policy means that it's basically cleaning up unused untagged images. And it shows. And there's also like this thing called null resource, which is basically how you can build and push a Docker image from within your Terraform file. So if I'm going to press yes here, what it'll do, it'll create the ECR repository, and it'll fail.
Of course.
And why would it fail?
Because of that null resource that you just mentioned. No, that's get login password. It's an authentication problem.
No, it's this.
Oh, interesting.
This is the whole path thing. Remember we just talked about it. That's the reason one of the reasons we need it. Because the ability to actually identify the relative path to a source file is not trivial, right?
Yeah,
you can't do it without additional information,
right? Because now
you can see that it's built the image and it's pushing it to the repository. And so that's what the null resource is doing. And once this whole thing is pushed, we should see the Helm chart starting to get created. And you see this thing is starting to pop up. And we'll see it getting pulled in a second. It takes some time. Fargate takes some time to schedule compute capacity.
There, because it doesn't work with an existing node and just add a pod.
Yeah. So you see now it basically took 41 seconds to basically allocate a machine, and then the container started. So if the EKS cluster would have like capacity, they manage node groups, then it would take very quickly. It would take like 5 seconds to get started, which I think we can there's actually support for that, but I chose to use Fargate too. And so now if we look at this, basically our little front end here, the ingress will probably take a little bit to stabilize, as I said, but there's also an ingress. We can try and access it. There we go. There's
nice, man. Wow, this is interesting. This is impressive.
And I'm not going to show you because we don't have time, but there's actually cross-service communication working also. So I'll just show you how it looks. So here's the microservice example. So let's say we have this producer resource workload, which is not public. See, there's no public here, and there's a consumer resource, consumer workload. The consumer takes an environment variable with the producer's URL.
Can you show how you're using it? In the code?
And inside it basically says, producer URL, and then I'm just doing HTTP GET, right? Over here.
And that's supposed to work for both internal and...
That works both for, I think maybe for internal, I can show you. for the, I mean, I can probably show this to you both for internal and non-internal. Let's see. Wing it test microservice. Closing this guy, and this guy, and this guy, and this guy. There we go. And so this guy is basically sending a request to the consumer, right?
Right.
And the producer result contains the
Nice.
so basically this is the result that comes. It basically changed the output.
Interesting.
And if I want to be very bold, I can.
By the way, does wing test also works with the value file?
No, because wing test is, I mean, currently no. Oh, you know what? Maybe it does. Maybe it
should,
does.
right? I mean, I want
Like
to
the
know.
TFA, yeah, the TFA database version.
Yep. I think you're trying to show us that it's going to work, right? That's what you're showing us, the distance to work.
Maybe until while this is working, I can just give you a quick tour of like the code.
Okay.
So basically, this is the simulator version workload. Implement. Look at this.
There was a reason we asked you to enlarge the font.
Sorry. So see this? Blink.
Yep.
I'm showing you go to definition.
Yep.
So basically, the API is iWorkload, and it has start and stop is actually something that we probably won't include. But there's a URL in the internal URL thing, and this is the container options, what we've seen earlier. And then this is basically implemented using a cloud.service. So there's basically a cloud.service underneath, which is this local service. I'm not going to go into every detail here, but basically what we're doing when it started is basically if it's a local path, then it's doing Docker build. Otherwise, it's pulling, running, starting the containers, retrieving the external ports, everything, right? So that's the local.
So going back to the question Chris has asked before, the local implementation of this basically just runs Docker.
Exactly, just runs Docker, orchestrates it through Docker.
Yeah.
And the AWS implementation is a bit more involved, obviously. But if we look at it from the workload perspective, it's actually pretty cool. Like you can see that it's doing cluster get or create. So it basically goes to the EKS cluster class, and it says get or create cluster, and it receives an iCluster. So if you go to get or create, then you'll see that iCluster is basically some interface that implements cluster attributes, which is basically these three.
Yeah. So it's
basically a reference.
Yeah, it's a reference to an existing cluster or to the one that we just created, right?
Exactly. And there's also
it's a read-only reference, right?
It's also a singleton at the app level. So if I have multiple workloads and I'm not referencing an external cluster, it'll only create one, right? Like it won't create an EKS cluster for every workload, right? At least. And so all this goo here, and I think we should definitely do something about it, but all this goo here is how to create, basically the way to create singletons in Wing. So basically, I'm not going to go into that, but that's a mess.
Yeah, it's going over the tree.
And yeah, exactly. And then what you see here is basically the stuff that reads from the EKS from the values. There's the values file. So this is basically the way to read it from the values file.
Oh, so you're actually reading it from a value. The values file. How do you do this? The values file.
Actually, I created like this class that represents the values file. See values.w.
Yeah.
and it basically reads. It has some environment variables. We need to put this needs to be part of the SDK.
This should be part of a mechanism in the SDK. Makes sense.
Exactly. But I was playing around with that.
Interesting.
Yeah.
So again, this is public, right? This entire Elad Wing containers, right?
Yeah.
Awesome, man. This was a great demo, Elad. I was skeptical at first because I know you have very...
Okay, now it's not going to work. So let me see.
Let me get it back.
There we go.
Wait, we're not seeing it. We're not seeing it. Okay. Does it work?
Yeah.
Let me show you. Let me remove the banner for a second. Oh, nice, man. Awesome. So what we're seeing right now is the same thing we saw in the Wingit command. We have two containers talking with each other. Then the mechanism is the add environment, or basically the environment that you put. Can you go back to the code for a second? Not go back to myself, seeing myself as inside myself.
Microservice test. Yeah, this guy.
So this thing, the producer URL, the producer.internal URL, this is awesome. So now inside that image, we have the environment, and we can just access, and you're doing a fetch on it over it.
Exactly.
Very simple, and very powerful kind of an ability to kind of combine kind of code within.
Yeah, it's basically kind of starting to look at the microservice support, right, in a sense. Awesome. And it's using DNS, and it's so hairy. This whole thing is like, oh my god, I can't believe everybody's doing this. This is, and I'm using EKS, which is a managed Kubernetes solution, and I'm using Terraform modules, which are abstracting a lot of the details of how to define the resources, and still it's like crazy hairy. You look at the code of the eks.w file, even that code, which is like, again, as I said, using a lot of the Terraform modules and EKS stuff, is not straightforward at all. But yeah, I think like this is exactly why we're here.
Yeah, and another level of abstraction. Basically, we're saying let's talk about workloads, replicas, what we care about.
Yeah,
this was awesome, man. This was really fun, and it worked. And it worked.
Yeah, I mean, I'm sure there's so many details. I think that it's going to take It's going to take some time for this library to mature and stabilize, and there's definitely.
Do you have a next step for it? Do you have the next thing you want to do with it?
So first of all, the public URL is not supported yet on AWS, so that's something that I need to.
Okay.
Yeah, I have like a whole roadmap here.
Okay.
And I want to get to the point where I can support. I can access a Redis resource from the container. So
right.
So ex.redis from within the container.
But you need Redis doesn't give us right now a URL. So how are you going to
Redis gives us a client? Redis does give us a URL.
We have I don't think we'd have it, do we?
But yeah, it might need to make some changes in Redis. And I think the hardest part is actually not the URL, is the fact that the VPC that I'm currently deploying the cluster into is not the same VPC as the Redis. And so the first thing that I'm going to need to do is basically merge these two VPCs together into a kind of like a system VPC, because the system VPC is not configured properly for EKS. So we actually need to like create some kind of a default common denominator that will support. And then it's going to be possible to actually connect from the container to Redis.
Right.
It's going to be pretty challenging. I think there's going to be some security groups involved, and every time security groups are involved, I'm like, my brain is exploding 12 times when I need to understand exactly.
I have a feeling that the person who should be worried is Hassan. I don't know why. That's what I'm feeling.
So yeah, Redis. I think the other thing that I want to get is something like cloud.bucket, right? Like be able to actually access cloud.bucket. Cloud.load balancer. I don't know. That's actually a good question. I'm not sure. Cloud.load balancer is is a pretty low level abstraction. I mean, there
I
is a
think
load
that
balancer, right? Like there is a
the,
load balancer here.
the Ingress is the load balancer in this example, right? Ingress
Exactly.
uses
Yes,
ALBs in this example.
exactly.
Yeah.
And so currently, when you're basically saying I want this workload to have a public endpoint, it automatically assigns a load balancer for it.
Yeah.
So it's kind of like FlyIO in a way, right? Like when you're deploying a FlyIO with machine, you basically get a public URL for it. Yeah, so it does have its own ingress mechanism, basically. Oh, you mean
Yep.
like within the workload?
Yep.
Yeah, it's been something that I was originally thinking maybe we need some support for ingress routes, right, in the workload API, but the more I'm thinking about it, the more I'm not certain that it's actually needed, because if you look at other container abstractions like FlyIO, for example, or even things like render or other types of like container-based paths, high level APIs, in most cases, you basically just get a public DNS name for your container, right? Like you basically deploy a container and you get here's the URL, you can access it to whatever you want, right? Like this idea of like having like a single ingress that has ingress rules that route to different workloads within the same system. I don't know.
I've used this in the past. We basically we had a monolith, and the monolith was given a service in different passes, and then we took different passes and we put them in different workloads. So eventually, you have a single ingress, and kind of like an ALB. You basically
Right.
kind of.
Yeah. Anyway,
Okay.
we'll experiment with
We'll
that.
see. We'll see. Yeah. Awesome. This was great, man. This was exciting. It's wow, a lot of work. Great job, man. Yeah. And I think we're 26 minutes out of time, which is
Promiscuous mode.
Yeah, which was fun. I kind of enjoyed it. Thank you, Mark. Thanks a lot. Thanks for this hour and a half, and thanks for the viewers. And we'll see you in 2 weeks. And stay safe, everyone.
Stay safe. Bye. See you later.
Bye.